Hi, good morning, everyone. Thank you very much for joining us for the SciFinder-n webinar. Okay, so first of all, a quick introduction. For those who've seen me for the first time, my name is Pamela. And I'm based in Singapore. So, typically we would, visit the university and have the training there. But of course, with the pandemic situation, we'll have to do an online training instead. Hopefully we'll be able to visit you guys soon. So I'm typically in charge of trainings, all right, and SciFinder-n, sorry, SciFinder-n, one of the products that I kind of take charge of the training. All right, so one of the main kind of objectives of the training is to introduce the new version of SciFinder-n to you. For those who have been using the old version of SciFinder, do take note, we have decided to switch off, right, the access to the old platform on the 1st of August, right? So I think after 31st July, we will be turning off access to the old platform. Okay, so if you have been using the old version, please start using the new version, and I can assure you that you will like the new version better. Okay, for those who, this is completely new to you, then there's no difference, all right? You just learn the new platform. The other thing to note is that you will need to register for an account. If you're a new user, you will need to register for an account before you can start using SciFinder. For the people who already have an existing SciFinder account, you can use the same username and password to log on to the new SciFinder-n platform. All right, so I'm gonna share some introduction slides on what SciFinder is about, and we will then go into the live demo. Okay, so this is my slides. I think I will maybe stop my video. Okay, full screen mode. So SciFinder-n. So like I say, I will give a quick introduction and talk a little bit about the registration of an account for the new users, okay? And then we will go through the three main types of searching in SciFinder, which is reference, substance, and reaction searching. And then there are some new features in SciFinder-n that were not previously available in the old version, such as ChemScape analysis, retrosynthesis, as well as biosequences. Okay, so I will also quickly cover these three new features in SciFinder-n. So for those who are new to SciFinder, new to CAS, so CAS is one of the divisions of the American Chemical Society, and we are the organization that created the SciFinder-n solution. Okay, so what we do at CAS, we curate scientific content. They come primarily from journal articles as well as patent documents. We do the necessary indexing and make them available and searchable in SciFinder-n. So these are some of the scientific disciplines that we cover. We have up to 80 different sections. So I'm just giving you a snapshot of some of the areas that we cover. So anywhere from, the physical sciences, more, and all the way to kind of life sciences. Okay, it's a very wide spectrum of areas. So the unique advantage of SciFinder-n is that we have a team of scientists that curates and index the information such that it's searchable, it's discoverable. Okay, so we have a team of scientists. They receive the full text, whether it's a journal or a patent. They will read through the whole article, right, from the main journal all the way to the supplementary section, and they will highlight or index the key topics or key concepts that are being discussed in the paper. They would also note down any key substances or novel compounds that have been discovered or any new reactions that have been reported, okay? And then all this information is extracted out from the full text, added into SciFinder-n, and then you can actually search and find it. And of course, the reason why, we still have a human curated process, it's because a lot of times scientific information is written in a way such that it's impossible to have a machine or an algorithm to replace this process. So for example, if someone writes the desired product, you can imagine if it was a software read this paragraph and trying to understand what the desired product is, they wouldn't be able to know, all right? On the other hand, because we have a human scientist trained in that area of science, when they read it, they are able to tell that, okay, desired product, it was mentioned, maybe the structure was mentioned a few pages ago, and then they will connect the dots for us so that when we search for this structure, for example, to find the synthesis of this compound, we'll be able to find this corresponding paper, okay? So this is an example of how a reference record looks like in SciFinder-n. So it's not a full text database, all right? So we provide the full text links, but SciFinder-n itself, you can't download the full text. So you can see title and abstract, and then we have a section here called concepts as well as this. So all this information is based on what is reported in the full text, and then we add it in to SciFinder-n. So have a peek at all the important information without having to go to the full text yet. All right, so like I mentioned, we will be talking about this 3 main ways in SciFinder-n. Okay, so before I get over to the platform, I just wanted to talk about the registration portion for those who are first-time users. You will need to go to the website and look for the registration link because every university has its own unique registration. Okay, so once you can find the registration URL from the library website, click on it and you will need to go through this few stages to complete the registration. Okay, so typically it will ask you to accept the license agreement, and then you have to fill some information here, create your own username and password. It has some criteria, so you can click on tips to check out what is the criteria for the username and password. Once that's done, go to your university email. So remember to only register for SciFinder-n using the university email. Okay, so that's how we verify that you are a student and staff of the university. So go to your university inbox and check for a confirmation email from SciFinder. It should look something like this. And then in the email itself, there will be a confirmation link for you to click. All right, so once you click on it, then you will complete the registration. And then remember to go to SciFinder-n instead of the old SciFinder. So at the moment, you will have access to both, but come 1st of August, it will be just SciFinder-n, okay? And then another thing to note, when you are doing the registration, you will need to be logged on to the university's Easy Proxy network or portal. Okay, so you need to be on university network to do the registration. Okay, now that all this is done, we can go into the more interesting portion, which is the live demo. So let me just, are there any questions? Okay, I don't see. All right, so let me just switch to the, I'm trying to get out of presentation. All right, got it. Okay, so should be able to see my screen right now. I'm going to the home page. Okay, so just take note, right? This is the URL SciFinder-n. If you accidentally log on to the other platform, the old version, it will look completely different from this. All right, so just make sure you see this home page. Okay, so once you've logged on with your username and ID, like I say, this is the landing. And on the left-hand side is all the different search options. Okay, so we will look at the first reference searching. So reference searching, it's typically where you do a keyword search to find literature, right? It could be journals or patents. So we'll start with a simple topic as the first example. So I'm going to type in silver nanoparticles. And then you can see that as I'm typing, we get a list of auto text suggestions. So you can definitely use one of the suggestions here if it matches your needs as the search phrase, and hit the search button. Okay. So this is actually that's a wrong spelling. All right. So I was thinking, why do I only have 60 hits? So make sure you choose the right when you're selecting from the auto drop down list. Okay, select the right one. So silver nanoparticles, okay, over 800,000 hits, and this is the result. Okay, titles, abstracts for each of the reference article that matches our search query. So you see the corresponding hit highlighting in blue as well. All right. So as a default, the answer set is sorted by relevance. So you should see the references that matches your search query shown to you first. There are other ways to sort the results. All right. So if I change it to publication date, okay, so you see in this case, this is the most recent article in our answer set. However, if you look closely at the title, it isn't actually talking about silver nanoparticles. It is actually cerium oxide, but it has the hit highlighting on the word nanoparticles. So what is happening here is that when we put in a search phrase that has two words, right? So SciFinder will of course try to find the hits where these two are found, both of these two words are found in the paper. Okay, and then it will then find references that only contain silver, and in this case only containing nanoparticles. Okay, so when you sort by relevance, it doesn't make a difference because you will see the references that contain these two words shown to you first. All right, but if you want your search to be more specific, okay, so in a case of silver nanoparticles, we can actually do a double quotation, what we call an exact phrase search, so that in all our answer sets, silver and nanoparticles are found next to each other. Okay, so I'm going to rerun the same search, but with the double quotation added. So this is something new. Okay, you can't use this sort of symbols in the old version of SciFinder. So SciFinder-n, you now have a lot of control and flexibility on your search. Okay, so you can see here a much smaller answer set, right? And then silver nanoparticles. And in fact, now because I have a specific search, I would actually just load my entire answer set. Okay, because I know everything must contain silver and next to each other. Okay, so now let's take a look at some of the filters on the left-hand side that can help us to sort of narrow down, right, our current answer set to the ones that are most relevant to what we need. We'll first take a look at this substance role filter. Now, this filter is very unique. You only find it in SciFinder-n. And in this case, the substance role is actually applying to silver, okay, because we have a specific substance in our search query. So if you are interested in a certain aspect of silver nanoparticles, I'm going to expand the substance role filter. All right, so depending on what type of research are you working on, right, in relation to silver nanoparticles, you can choose the role that is most suitable so that it quickly narrows down this huge answer set that we have only to the journals or the references that are discussing something about silver nanoparticles that is of interest to you. Okay, so for example, if I'm looking at synthetic preparation or different ways to synthesize or to prepare silver nanoparticles, I can see this as a substance role. All right, so there are 8,000 references. Okay, now I'll show you how this substance role is actually working. So I'm going to move down to this second reference here. So from the title, it's already quite clear that it is talking about preparation of silver nanoparticles using a sonochemical method. All right, so if I go into the reference detail by clicking on the title here. Okay, and like I mentioned, at CAS, we have scientists that do the indexing, right? So there are the key concepts being discussed in the paper, as well as the key substances that are being used, all right? So silver is our compound of interest. And if you look under silver, we not only just give you the CAS registry number, the name of the compound, the structure, but we also tell you how this compound is actually being used in the paper. Okay, so you see here that it states synthetic preparation. So that's the reason why when we select synthetic preparation role, this reference is filtered out for us as being relevant. Okay, now let's look at another example. So this is another way of synthesizing silver nanoparticles, looking at biosynthetic methods. So again, if I go into the reference detail, all right, the same thing. We have here key concepts, right, that are being in the paper. If I move down to substances, okay, so can I ask that everyone mute yourself if you have forgotten? Yeah, so that just in case, all right, so substances, again, right, we have silver, and you can see here there are many roles applied to silver in this paper, but one of them is the synthetic preparation role that we have selected. Okay, so this is a very useful filter to use if you have a large answer set of references and you want to quickly find those references that are discussing your subject of interest in a way that that's relevant to your research. Okay, the other thing I want to mention, this specific reference, you notice there's another additional section here called Medline. Okay, so in SciFinder-n, we actually have the Medline database, the Medline reference database included. So when you're doing literature search, especially for those who are working, when your research area is the kind of biomedical sciences, life sciences area, you may find Medline a very useful reference database. So in SciFinder-n, you can search for both the CAS reference database as well as the Medline reference database at the same time. Okay, so this is the indexing done by the Medline database providers. So again, giving us some ideas on what are the key points of this paper. Okay, so overall, all this information, right, role information, Medline medical subject headings, concepts, together with the title and the abstract, they are provided to you so that you have a good idea of what this paper is going to be talking about. And then you can decide, right, is it relevant? If after reviewing all this, you think it's relevant, then you can go ahead and download the full text, all right? Instead of, having to download the full text of every single result you find in your search, okay? So we have the full text link here. This will, when you click on the link, right, it will lead you to the publisher's website, okay? Whether or not you can read the full text, view the full text will be dependent on the university's subscription to this publisher. All right. So for example, I have no access, right? It asks me to purchase the article in order to view the full text. Okay, but if your university subscribes to it, then you'll be able to download the full text just by clicking on either this or this. It's the same thing. If you click on view or view all sources, then there is another link for DOI. Okay, so let me just close this and go back out. So we've talked about substance role filter. Then of course there are many filters here, but most of them are quite common. So I won't spend too much time on them. I'll just focus on the ones that are unique to SciFinder. Okay. The second filter that is special or unique to SciFinder-n is the concept filter. All right, so concept filter, so I have already selected synthetic preparation. So we'll do further filtering. Concept filter, so if you recall earlier on, I was showing you the key concepts, the Medline medical subject headings, right? There are many phrases or keywords listed in those two sections. So basically this concept filter will allow us to filter down references based on the phrases and keywords that are found in either the concept section or the Medline medical subject headings. So these are all the key points of the papers or the references in our answer set. All right. So under concept filter, there are a few tabs. The top count tab basically summarizes, right, in our entire answer set with the commonly occurring keywords. So this actually gives you a very nice insight into what are the commonly occurring topics in your area of research. All right, so we searched silver nanoparticles, right? So of course, nanoparticles comes up at the top. Silver is also at the top. And then these words like particle size, surface structure, nanocomposites. So this would tell you that, okay, when people are looking at this area of research, these are some of the other topics that they consider as well, right? Particle size, surface structure of the silver nanoparticles, okay? And then we also see antibacterial agent. So this should also give you a, strong hint that likely a lot of times these silver nanoparticles are being used for their antibacterial properties. Okay, so you can go through the whole list and look at all the different commonly occurring concepts, and you'll be able to learn a little bit more about the research you're working in. Okay, so other than just viewing this and searching to find concepts, you can also search directly. Okay, so if I go to, of course, alphanumeric, all right, but I'll just go into the search tab. So alphanumeric, you can view concepts alphanumerically, but I think if you have something in mind, it's probably quicker to just go to the search tab and try to search it. So let me try and relaunch this again. Okay, I'm not sure what's happening. Let me try again. Let me try refreshing this page. Okay, let's go into concept. Well, maybe I'll just have to let it load. Okay, good. Okay, like I say, we can search for something that we are interested in. So maybe I'm interested to see, how have people used plants, all right, or plant extracts to synthesize these or prepare these silver nanoparticles. So I can put in, I just search for plants. Oops, sorry, just get that spelling right. Plant. Let me just make sure that everyone is on mute. All right, so I have a question asking if we can download the references directly from the SciFinder website. So I don't know if I've covered this before you asked this question, but I'll go through it again about getting to full text, okay? So I've searched for plant, okay? And then you can see that it has found all the concepts in our answer set that are related, that contains plant as part of the concept, okay? So we can scroll through to see, find the concepts that are interesting for us. So for example, plant leaves. So these could be papers where they maybe extract out the silver nanoparticles from the leaves of some plant. Or we can, let me see, right? Or we have a more generic, just plant extracts. So maybe I'll pick this one over here. If you are interested in all the different, like plant stems, plant shoots, and everything looks interesting to you, you can actually select, click on this to select all. Okay, but I'm just going to pick plant extracts. All right, apply. So this is narrowing down our references to those that now, right, we're looking at biosynthesis, but using plant or plant abstract. So you can already see the answer sets have changed quite a bit. Geranium leaf, and then this green synthesis. Okay. If I scroll down further, you'll see, different papers where they use various parts of plants for the synthesis of silver nanoparticles. Okay, so let me just pick one example. Maybe I'll pick this one, okay, the geranium leaf. So I'm going to go into the reference detail again. And so remember, we selected plant extracts, all right? So if it's not found under concepts, it should be found under Medline, medical subject headings. Okay, so that's why when we selected the concept plant extracts, it's able to find this paper for us. Okay, and in fact, if we have selected plant leaves, we'll be able to find this paper as well. So you can also see another relevant concept, plant leaves, listed under the Medline medical subject headings. So this concept is actually really good if you want to kind of do a broad search, right? Just a search to cover all the references that looks at using plants to synthesize silver nanoparticles. So you don't actually have to put in a specific type of plant in mind, right? You can use these concepts to just pull everything back, and then it will tell you, and it will show you in your answer set different examples, different plants or plant extracts being used. Okay, so to address the question about downloading the full text, all right, so like I say, from SciFinder-n, there is this full text links. Okay, so we can select DOI. So what it does actually is you don't actually download the full text from SciFinder-n. What it does is that it actually redirects you to the publisher's website, where you can then download the full text if the university has access to the full text of that paper. Or if it's an open access paper, then you'll be able to download as well. Okay, it looks like this might be open access. Let me take a look. Okay, no, right. So you can see I don't have access. It will ask me to pay for it. Okay, so use the full text link. It's found in the reference detail. It is also found in the result page, right? You can see here, there's a full text link here as well. Okay, so other than the filter options, there is also the option for you to exclude something from your answer set, right? So you can say that I don't want to see certain types of answers, remove it from my answer set. So I'm going to switch over to exclude. Okay, so from now on, anything I pick will be just removing it from our answer set, okay, because now I'm under exclude. So I might say, well, I don't want to look at maybe review papers. Okay, I want to focus in only on papers that are talking about the most recent science, okay, and developments. So, all right, so earlier on you saw an error message. So typically the first thing to do is just hit the refresh button. Usually it will then, it should be okay after you read. So now you can see at the top, right, we have filtered references based on synthetic preparation, plant extracts, and we have excluded documents that are reviews. Okay, so this is how you can use the exclude option. Now I'm going to switch back to filter again. And I want to show you the other document. I mentioned it a few times, but we haven't come across it. So I'm going to use the filter by to pick. So you can see here patents, right? So in SciFinder-n, we include both journal articles as well as patents. So this is an example of a patent reference. So for a patent reference, typically you will notice that it has this patent pack icon. So for most of the patents, well, I shouldn't say most, because we cover 64 patents from 64 countries or 64 patent authorities. Out of the 64, 44 comes with patent pack. So with patent pack, you will be able to download the full text patent from SciFinder-n itself. Okay, so I'm going to use this as an example. So if you see a patent, right, and if it so patents may have interesting scientific information as well. Okay, such as in this case, you might want to see how they use a plant seed extract to synthesize nanoparticles of silver. There are 3 patent pack options. The PDF, as its name suggests, it's just the PDF. The viewer contains the PDF, but it also has a substance window on the left-hand side. So I'm going to show you this. Okay, so this is what I'm talking about. The key substances are shown on the left-hand side, and then this is just a regular PDF. So the viewer version is a little bit more useful because you don't have to go through every single page to find where is it that they actually talk about the synthesis of silver nanoparticles, right? So instead of having to read everything, I can just go to silver, click on page 14, as shown here. All right, so you can see here, it's highlighted in purple, and we have the corresponding marker highlighted in purple in the patent. And this is where they actually talk about the preparation of the silver nanoparticles. Okay, and in fact, the markers work both ways. So if you are reviewing the patent and you see another marker here, you can click on it. And in this case, this is silver nitrate. Okay, so it's just pointing you to the corresponding substance in the substance window. And the substances here are all clickable in the sense that, all right, so if I'm interested in silver nitrate or I want to find commercial suppliers for silver nitrate, I can click on the image of silver nitrate to get this pop-up window. And from here, I can either look up properties and other information of silver nitrate. I can find suppliers. All right, I can even go to find other literature related to silver nitrate or reactions involving silver nitrate or even how to synthesize silver nitrate. Okay, so you can do a further search on any of the compounds in the so let me show you another example. Okay, so you have the patent pack icon here. You can also go into the reference detail. And you can see here, we have the viewer button, and there's also the viewer button here to open up something similar to this. But in the substance detail, what is also interesting is that you can see all the key substances, right, with the structures. There is also a patent pack icon. Okay, so what I can do is I can come here to silver and click on the icon here so that when this patent pack opens up, you can see it has already selected silver directly for me. Okay, and then sometimes you have multiple markers, it's possible. And then we have the synthesis of silver nanoparticles written down here. Okay. And then if you're wondering what's the PDF class, I'm just going to open it up and show you. It's essentially just a regular PDF, but with the compound and page number information as a table listed at the end. Okay, so I'll scroll all the way to the end. So it's just something like this. You have your compound, the name, CAS registry number, and page numbers. Okay. So let me close this. Close this. And also just to mention, when we are in the reference detail view, okay, this is the reference detail view. The substances here, you can also click on all of these structures, okay, to give you the same pop-up window that we saw earlier, to then run a further search on, in this case, polyvinyl alcohol. Okay. All right, so let me go back out. Okay, so after we've done, our search, we've applied the different filters to narrow it down to a answer set that is, relevant to what we're looking for. We can save this search together with all the filters so that we can easily rerun it, and we don't have to go back and hit on all the filters again. Okay, so click on the Save button, give it a name, and while saving, you'll be able to also set up alerts. Okay, so if this is your research project, right, you want to be informed when something new enters the database based on our search query and all the necessary filters we have applied. Just select as available, weekly or monthly, save it. So it goes into the save folder found here. Okay, so you can see this is what we've just saved. I can rerun it as remembered the filters that I've applied. I can always change my alerts or turn it off. And you will see that there are some of my saved answer sets that have a second button called View Saved. So this is because I have actually selected specific references to save while saving the search. All right. So what I mean is that if I go back out, okay, if I selected these two references and I hit save again, you will see that in this case, I'm saving the search as well as selected results. Okay, so you can also save specific results in the answer set if you want to. Okay, so let's look at one more example before we go into substances. Okay, so if we have a longer phrase, right, this is just silver nanoparticles. If we have multiple keywords that we don't want, we want both of them to be in the reference, but it doesn't have to occur next to each other, how would you phrase such a query? Okay, so I'm gonna use, okay, to find references that look at metal, trace metals found in a certain type of fish. Okay, so I say metals, and then I use the AND operator. Okay, maybe I'll just say metal, right? Not AND operator. Okay, Boolean operators. I used AND, CBES. Okay, but for CBES, use my double quotation so that CBES is always next to each other, and then I have metal with the AND operator. Okay, so I'll run the search on this. Okay, so all the references should contain the word metal or metals, as well as CBES. All right, I'm just going to go ahead and load the full set. So sometimes if you look at the title and the abstract, right, you don't see CBES highlighted here. Remember, we have a concepts section. So I'm going to go into the reference detail, okay, and check out. Okay, so we have CBES listed here. So this is what I mean by when we do the indexing, we look into the full text. So you can sometimes find things that are actually not mentioned in the abstract. Okay, so the search will look at the title, abstract, as well as the concepts. Okay, and you can see many other types of seafood, okay, as well as Medline. It will also search in the Medline subject headings. All right. Okay, so let me go back out. There's one more filter that I've not mentioned yet, which is the search within right at the bottom. So if you have your own additional keyword that you want to filter down your answer set by, right? If you don't want to use the concept, the keywords in the concept, you have your own keywords you want to, quickly do a filter or refinement, you can just type it here. So maybe I want to focus it on references that look at maybe the fish from Malaysia or Asia. So you can see here, I'm also using another Boolean operator, or, okay? So I'll look for Malaysia or Asia in my current answer set, hit the find button. Okay, so you see additional hit highlighting of Malaysia, right? Malaysia, okay? Or, finds Asia, you'll be able to see hit highlighting of Asia. And then just to show you, right, this is a different topic, right? We're talking about heavy metals. So if I go into the reference detail again, all right, so this looks at the test these different heavy metals. So if I look under substances, you can see that the heavy metals are listed, right? Because they are important in this paper, they have been tested. But you will notice that in this case, right, it's a different topic, so it has been assigned different types of roles compared to what we saw earlier. Okay, so it has been assigned with an analyte role because it has been analyzed, right? And in this case, the heavy metals are a pollutant, so it also has been assigned a pollutant role. All right, so this is how all this information is very insightful when you are reviewing answer sets. All right, and then one last thing to show you. So for each reference, if you're interested, you can see how many times it has been cited by, and then if you go down to the citations, you will see what other references cited by this paper. So the ones that are hyperlinked are the ones that you can find in SciFinder-n. So some of these are like websites, so you don't actually, it's not in the SciFinder-n, so it's not hyperlinked, but we have a citation map feature so that you can see at one glance, this paper and what paper has this reference cited. Okay, so this is cited by, and this is, cited by, and then this is citing, right? Other people that have cited this paper over here. So you can click on any of these reference titles to view the abstract, okay? And then of course, click on the title here again to go to the reference detail. Or you can do some filtering first, right? Because sometimes you have long list of citations. It's tedious to read every single abstract. So you say, I want to focus in on the papers that look at, I'm just going to pick one concept here. Okay, this is of interest for me. I select it. Then it's only showing us the three references that contain this concept that we have selected. Okay, so all right, so this is for reference searching. So I'll just do a quick check to see if there are any questions. Okay, so I don't see any questions. So actually, all the searches that we have done have been saved here. Okay, so it's only when you apply filters, when you have processed your results set, that's where, and you want to be able to save all the settings that you have applied on your results set, that's where you have to manually the search, right? If not, the first initial search that we have done is automatically saved for us. In fact, if you go to the history button, you can see, you can even go back to look at searches that you have done months ago, right? Every purple dot indicates that SciFinder-n is being used. So a quick tip is to click your mouse on the end date and then select the date that you want to review the searches. All right, so 9th April. All right, so these are the searches that I've done on 9 April. Okay, so go to your search history to, if you want to review, to remind yourself searched in the past. All right, so I'm going to go back to the home page and we're going to look at another way of searching, another type of search rather, which is substances. And this will be especially interesting for people who are doing a lot of, are looking at a lot of chemical structures, right? Sometimes it's really hard to search via keywords. So you can actually put in chemical structures to search, but we'll first start with a simple substance search by name, okay? So since we've looked at quite a bit of inorganic oxides and inorganic substances, let's switch gears a little bit and take a look at organic compound. Okay, so I'm trying to type it out, jafetinib. Again, you know, you have the drop down to help you spell, especially some compound names can have quite a long spelling. You can use it to double check and select it. So jafetinib is actually a drug, anti-cancer drug. So this is the structure of jafetinib, and you can click on references to find the relevant literature, relevant reactions, and commercial chemical suppliers. All right, or we can go into the substance detail. So similar to a reference for substances, they also have a substance detail where you can find key physical properties. This is a more extensive chemical properties table. Okay, sometimes it has values like you see here. Sometimes it says see full text, so it just, you have to refer to the source here to get the data point that you're interested in. So this is saying reference 1 to 14, which is over here, right? 1 to 14. Okay, so these 14 references will have the ADME properties of jafetinib reported. Way to go to the references, of course, just to right click on one of the links here and just open this in a new tab. Okay, so this is back to the reference detail that we saw earlier on, and you can use the full text link to go to full text. Okay, then you have experimental spectra. Again, it can be available in SciFinder-n itself, such as in this case, you can view the NMR spectra, or you may have to go to an external source to view it, but at least we tell which paper you can refer to for the chemical shifts. For compounds like jafetinib, which is a drug, it has an additional bioactivity indicators. So you can imagine jafetinib, you know, has been reported, is quite a common drug, right? So it has been reported in the literature many times. And these are all the different bioactivities that people have kind of looked at in relation to jafetinib. So this is a very nice overview. But typically, if you see a specific bioactivity that has a lot more references, such as in this case, right? This is over 6,000 compared to all these few hundreds, right? So this is a very strong hint. If you don't know what type of drug jafetinib is, if you see this, its chances are likely that this is an anti-tumor drug or anti-cancer drug. Okay, so the number of references can sometimes give you a hint on what is the most well-known bioactivity for a compound. So if any of these bioactivities are interesting for you, so maybe you want to see, well, how has people looked at jafetinib as an anti-HIV agent? I want to, you know, check out this set of literature. I can again click on the link, open it in a new tab, and this will be all the references, okay, that have kind of done that study. Okay, so other than bioactivities, there are also biological targets. Okay, so the same thing. It's the number here is the number of references that have looked at jafetinib in relation to the listed biological targets here, and you can right click and open them to pull back those references quickly. All right, so let me go back and talk about another way of searching. So we're going to do the same search on jafetinib, but instead of chemical name, we're going to use the structure to run the search. So I'm going to make use of the structure image that we have here. click on edit structure. Okay, so you can see this is a quick way to add a compound to the structure editor. And with this, you can run the search. Okay, so I have a chemical structure here, substances, run the search, right? Same thing, searching drafetinate, but by structure. So you can see the number of hits differs greatly, right? When we search drafetinate by, we just get this hit. But when we search it by its structure, we are able to find isotopes, right? So these are drafetinate, but carbon-13 here. Let me just zoom in a little bit. You can see here deuterated versions. And if I switch to the 2-component answers, okay, so it's still under estron, right? So these are salt forms, HCl salts, mixtures of drafetinate, okay? So when you do a structure search, you'll be able to find isotopes, salt forms, mixtures that contain drafetinate, right? Whereas when you search by name, you just get drafetinate, one compound only, okay? So it depends how broad an answer set do you require. Now with a substance search, you see these two other options, right? So I'm going to move to substructure. So this is interesting, especially for those who are doing structure activity relationship type of research, right? You're exploring different similar compounds, and then typically you will be trying to optimize a bioactivity. So with the substructure, all right, it will contain all the hits from the estron. So let me just get rid of any salt forms and mixtures. So I'm going to limit it to single component, and let me get rid of isotopes. Okay, so you can see with a substructure search, you get drafetinate, all right? And then you get compounds like this, which is structurally very similar to drafetinate, but this has like 2 methyl groups on this ring over here. So these are like analogs, close analogs of drafetinate, which might be interesting, right? If you are trying to maybe optimize certain activity around this starting compound here. Okay, so you might want to make minor modifications around different parts of the molecule. So you can see here, these are all, you know, it contains the structure of drafetinate, but it has some additional substituents here and there. So of course, not all substituents are small. If I go all the way to the last page, you can see in this case, whatever that is in blue is drafetinate, right? But this has a huge additional substituent. So at some point, you know, the substituents can get quite big, but the ones at the front would definitely be interesting. All right, so this is a definition of substructure. You still have drafetinate somewhere, just with additional substituents. Now, as for the last section, similarity. So similarity, you'll find answers from estron as well as substructure mixed into it. So let me get rid of, again, the isotopes. Okay, not containing isotopes. So we at least get rid of those answers. And then we get compounds like this, which doesn't have the blue hit highlighting. So if it doesn't have the blue hit highlighting, it means that it has a different chemical structure from drafetinate. Okay, so if you compare compound number 5, okay, maybe I'll compare this. Okay, compound number 3 to compound number 1, drafetinate. Okay, it's very similar, but it has the fluoro and chloro positions flipped over. So that's why there's no hit highlighting, right? Because it doesn't match the structure of drafetinate, but it's still 99% similar to it. Okay, so so for similarity search, you'll get to find similar compounds, but they may not have the basic drafetinate structure. Similarly to this compound, again, structurally very similar. The only difference is that this has 2 fluoros instead of a fluoro and a chloro. Okay. Now, with the structure search, when you do a structure search, you will notice that there is this ChemScape analysis button. Okay, so this is something that is introduced only this year. Okay, So I will quickly demonstrate what it is, but it's more relevant for people who are interested in patterns. Okay, so I won't dwell too much into this. So just to show you what I need to do. Okay, so I'm going to use the similarity answer set to show you the ChemScape analysis. Each time it can only pull over 1,000 compounds maximum. All right, so it's good to get your answer sets, your number of compounds below 1,000, such as in this case, so that which are the compounds that are being pulled over. Okay, so you get this nice visualization when you click on ChemScape. All right, so I will just do a quick introduction. Probably, in the future, we can do a separate session on this for those who are interested in patterns. Okay, so each of these columns or squares that you see here basically represents a compound. Jafetinib, which is our structure query, is actually the tallest one here. Okay, so you can see when I select it, you will see jafetinib. So the compounds here, they are positioned according to how similar they are to jafetinib. So if I click on something nearby, such as this, okay, just next to jafetinib, you can see it's very similar, it just has these two groups, the fluoro and the chloro switched over. But if I click something that's further away, so you can see this part of the ring is completely different from jafetinib. Okay, then the height of each of these columns here represents the number of patterns that it has been found in. So jafetinib is really tall because it has over 3,500 compounds. Something like this over here, if I click on it, you can see only 2 patterns. All right, so at a glance, you will know which are the similar compounds to jafetinib, which has been commonly out in patterns. All right. Then other than just viewing it this way, there are various types of analysis that you can do. So I'll just quickly demonstrate one. Current assignee, I can color code my compounds according to which organizations have actually filed a patent for these compounds. So I can pick Schering, the first one, okay, Schering. Then if I go to group 2, maybe I pick Novartis, okay, and then name it Novartis. All right, so you can see it's still only on jafetinib. Okay, just pick another one, Immunomedics. Okay, so for the first 3 companies that we have selected, all the patents have been on jafetinib. Okay, now if I pick, let's say, maybe jurisdiction, right? Maybe we'll start seeing, I'm just going to assign different patent authorities, okay, just to show you. Okay, for example, like this, you can see the different color coding according to the different patent authorities that I've selected. So of course you have to name it accordingly. Okay, so I won't talk about this any further, but this is the button to click on if you want to have a play with it. Just remember that you need to do a structure search first. Okay, it needs to come from a structure search, then this button will be available. All right. Okay, the next thing that I want to talk about is reaction searching. Again, for reaction searching, you can either do by structure, and in SciFinder-n, you can actually do reaction search by text, which is not possible in the old version. So using the same compound jafetinib, all right, I can, under reactions, type in my product or my target molecule's name, jafetinib, and then just run the search, and we'll be able to find, this time, reactions. Okay, reactions to synthesize jafetinib. So we have a substance role filter here that talks about either it's a product or a reactant. Now I can even go one step further and put in the word synthesis. okay, in my query. So in this way, I'm telling the SciFinder-n, please only show me reactions where gefitinib is the target molecule. So once I have the word synthesis here, you can see it doesn't even ask us to pick the substance, the reaction role. Okay, it knows that you are trying to synthesize gefitinib, so it will only show you reactions where gefitinib is the target molecule. The reactions are grouped by scheme. Okay, this is a big difference from the old version, right? For the old version of SciFinder, it's grouped by document or grouped by transformation. In SciFinder-n, it's grouped by scheme. You can also group by document if you want to, but there's no longer the group by transformation. So one thing about group by scheme, which is really useful, and I actually prefer this way of displaying the results, is that any reaction, all the reactions that are using the same starting materials to synthesize gefitinib have been grouped together for us under one scheme. So at a glance now, I can just look at all the different types of reaction conditions that have been tried out, right? Instead of having to my entire answer set to try and find them. Okay, so these are the scheme 1, 17 reactions, some of the different papers. It can come from the same paper or a different paper, but it will be a different set of reaction conditions. All right, so that's the grouping by scheme. And you also notice that for some of the reaction conditions, there's this experimental protocols link, right? So for those who are doing synthesis and find out how to carry out a synthesis in the lab, click on experimental protocols, and it will, all right, basically tell us how the synthesis has been carried out. Okay, so this plus this to give us this. All right, this is the procedure, and taken, in this case, taken from this reference over here. Now, if I go back out, there is an experimental protocols filter. So I can choose both, okay? And it's some slight difference between these two options. So experimental protocols is what you would typically see in the old version of SciFinder. But in SciFinder-n, we have another new experimental protocols called synthetic methods. So let me try and find one that has the new synthetic method protocols. Okay. Yeah. Okay. So this is the new new addition to SciFinder-n. All right. Synthetic methods, the same thing. It's giving us experimental details, but you can see the format is a little bit different from this, right? This is just like one paragraph. For this, we have reformatted, so it's very easy to see what is the product, what is the reactant, what is the step-by-step procedure, and even characterization data if it has been reported in the original paper. Okay. So yeah, so both are, you know, useful information. Okay, just that you know, one has a different format, and some reactions may have both formats available. Some, like what we see today, has either one option available. Okay, regardless, it's all useful information. So you go to this experimental protocols filter if you want to find experimental details without having to download the full text. Okay, so for reaction searching, you can also search it by structure, right? So what we have done so far is just by text. So let me just get rid of this. And now I'm going to explain a little bit on the drawing editor. So this is the same drawing editor that we saw earlier on when we were doing the structure search for gefitinib. Okay, so you can build your structures from scratch using the drawing editor here. But if you have already drawn something in ChemDraw, you can save your ChemDraw file as a .mol file, and you can import. You can see here we support the mol file formats. So you can import your ChemDraw structures into the CAS draw, or you can convert your ChemDraw structures into a smiles string and you can paste it here. You can see here that we support smiles. Okay. If not, just draw the structures from scratch. So the commonly used ring systems are found here. I'm going to select my benzene, click to add it to the drawing editor. Then I'm going to attach an oxygen to the ring. So I'm going to switch, select oxygen from the commonly used elements. We have the full periodic table here for your transition metals, your borons, and others that are not found here. Now I have my pencil and I'm going to attach the oxygen to this position. I can't click directly because it's just going to replace the carbon with oxygen. So what I need to do is to bring my pencil over. I will left click on my mouse. And when I left click, so don't release the mouse, left click and you move your mouse, you'll be able to see this bond formed here. And once you release, the oxygen will be attached automatically, okay? Then I'm going to have a ethyl chain on the oxygen. So of course, I can draw them out again using the click drag option, okay? I can do it this way, or there is a chain tool for drawing this sort of aliphatic chain. So this is a chain tool. I can draw, you can see the number of carbons according to how far you drag the chain, all right? So I'm just gonna leave it at 3. So you can do a reaction search on this just with, this is my target molecule, right? I can just do a reaction search just with this, or I can go one step further and specify that this is my product. If you don't specify the product, you can still run the search, then it will just give you the product or reactant filter option later on. All right, so I'm just going to go ahead and click the search. And then you notice that because now I have a structure added in for a reaction search, I actually have the option to create retrosynthesis plan. So we'll talk about this just in a moment. I'm going to run the search. Okay, you can see this is my target molecule. Now, when you do a reaction search by structure, just like the normal structure search by structure, you have the estron, you also have the substructure option. So in some cases, obviously, if we have the estron, it's always the best to be able to find something that is exactly what you're looking for. But in some cases, if you draw in something, it doesn't have the estron, the substructure may give you some interesting options as well. So just to show you an example of an estron, right? We scroll down to, probably need to go to the next page. All right, so these are isotopes, so I'm not going to bother with them. Let me just scroll all the way to page 5 so I can. Okay, so same thing as what we saw earlier on the substructure definition. This is the blue hit highlighting is our product that we have drawn here, right? But this just has an additional methyl group, okay? Or it can be additional chain here. So basically any substitution, this is a good example. So if you can't find an example of a synthesis with a 3-carbon chain here, you can most definitely consider the reaction conditions used for a 4-carbon chain, right? So you can use the same reaction conditions, you just have to modify the starting material. So substructure hits can be very useful as well, okay? But of course, if we have the estron, we'll just go with the estron. All right. So again, like I mentioned, because the reactions are grouped by scheme. So these are different ways to get to the same target molecule, right? Scheme 1, scheme 2, all right, scheme 2, scheme 3, another different way, all different options to get to the same molecule. So you can go through the entire answers, get the different options, or For reaction searching, there is also search within results, where I can put in maybe a starting material that I have in mind instead of going through the whole result set. Okay, so I'm going to say draw using current structure. This is my product. I'm going to put in a starting material. Okay, and I'm going to use the variable 2 for halogen. So I want to use aryl halide, right, where X can be any halogen to get to this target molecule. Okay, so click OK, click structure, find. So it will look for examples in our answer set where it actually uses an aryl halide, such as in this case. Okay, or even in this case and in this case. So it can be a chloro, fluoro, or iodo. All right. Okay, let me get rid of this. And of course, there are many other filters that you can play around with. You can filter reactions by product yield, by presence of certain non-functional groups, by catalyst or solvent that you want to use, okay, to help you find the best reaction conditions. Or even under reaction notes, you can say, well, I'm interested to use a microwave. Are there any reaction conditions that uses the microwave? Okay, I see a microwave irradiation. I can select it. Then it will tell me in my answer set which 2 of these actually uses microwave reaction conditions to get to the target molecule. Okay, so this is reaction searching. Now, if you have a more complex molecule and need to plan the synthesis, we have another function in SciFinder-n called the retrosynthesis planner. So this is not available. This planner function is not available in the old version. So one way to get to the retrosynthesis, so this is the molecule. Assuming this requires a multi-step synthesis and we want to use the retrosynthesis plan function to help us plan a synthesis, we can click on the structure, and then you'll see there's a create retrosynthesis plan option. All right. The other option is like what I've done earlier on, so actually draw out the structure. Okay, so I'm going to put in another example because this example is quite simple. So when we plan the synthesis, if we plan the synthesis, it's likely to be a single step synthesis, which doesn't really require the retrosynthesis function. All right, so I'm just going to draw something here. Okay. And I'm going to use the shortcut. This is the shortcut menu. So for some functional groups, it's already pre-drawn. So we can just click to attach it. So we don't have to draw this whole CF3 group manually. Okay, and then this is my molecule. All right. Click OK, and I'm going to just create a retrosynthesis plan. Okay, so it will bring us to this page. You can change some settings. Just stick to the default settings. Okay, 3 steps, up to a maximum of 3 steps in the synthesis, using common rules to predict reactions, and then I'll just create it. So the rules part is because, and you will see this in a moment, for the retrosynthesis planner, you can actually plan a synthesis for a novel compound. Okay, so this is an example of a novel compound. So you can see here, so synthesized, no one has reported a synthesis on it before. So if you try to search it, you won't be able to find anything. But you can use the retrosynthesis plan to help you design a synthesis so that you can try it out in the lab. Okay, so it has produced no experimental results. Therefore, it will come up with some predicted or predictive options. So that's where the chemistry come about. Okay, again, this itself can be another 30-minute topic, so I wouldn't do the details, but just know that you can put in a novel compound, something that you design yourself in the lab, draw it out, click on the retrosynthesis, create retrosynthesis plan function, and have SciFinder-n assist you in coming up with a synthesis that you can, try out in the lab. So the predictive, if it's a known compound, the plans will come out quite fast, but for a predictive, a novel compound, the predictive steps take a while. So if you see something like this, you can just close it and leave it to run in the background. You can see under my history, okay, you can see that it's generating plan. So once it's done, if you're still using SciFinder, it will pop up or come back to check. All right, so I've pre-run this earlier, so let me try and find it. Okay, so I've pre-run this before the session because I know it will take a while. So you will see that when it's done, it will actually say complete. Okay, so I'll just show you how it looks like. Just close a few tabs. Okay, so this is what I mean. When you have a multi-step synthesis, the planner can come in really handy. So this is my target molecule. So remember, retrosynthesis is going backwards, right? So this is my target molecule. So it's suggesting that you can break this down into these two intermediates. And this is in green because green means it's a predicted result. No one has actually reported this actual synthesis, but based on precedence, based on our entire reaction database with similar compounds, we think that this is one possible way that you can try. Okay, so this down into these two intermediates, and this intermediate can be further broken down to these two, and this intermediate can be then into these two simple building blocks. Now for these two steps, it's in purple. When it's purple, it means it's experimental reaction. There is an exact example in the literature where someone has reported this synthesis. All right, so this plus this to give you this. So let me just, okay, one more thing. So this is just one possible, okay? If I go into the steps tab, you can see that for each step of this plan, there are alternatives. Okay, so if you don't like what you see here presented to you as the first option, we can go into the flask, click on the flask, and look at the other options, possible options. Okay, so I'm going to see what else is suggested. And we can replace that step with another option. Okay, so this is the one that has been selected for us where, it's breaking the bond here. Okay, so maybe I feel like, well, I don't want to have an halogen here. I want to have maybe nitrogen. Okay, so I'll scroll through the options, scroll through different options. Okay, so this looks like a, this is what I want to work with. Select it. Okay, so once you make any changes in the proposed route, right? First of all, your intermediates will change, right? So once your intermediates change, the corresponding steps, the subsequent steps in the synthesis will change as well. Okay, so the steps behind have changed, and it will recalculate the overall yield and price for the new updated route. So basically at each step, you can go in and change it to something else if you don't like what is suggested to you, okay? Now, even for the experimental steps, the ones that are in purple, they also have predictive options. Okay, so let me just show it to you. So you can see experimental, predicted. So I can even change this to a predicted step if, I didn't like to follow what is already done in literature. All right, so I've replaced it with another predictive step. Okay, so again, it will recalculate everything and update the subsequent intermediates accordingly. Okay, so even for predictive steps, you notice that they also have evidence. Okay, so if you are trying out something that is suggested to you as a predictive step, you may want to know, all right, so what reaction conditions should I actually use? So click on evidence. All right, so the evidence obviously won't be the same reactant because no one has actually reported it, but it will give you some examples. So you can see it's also forming an amide bond on this aniline type of nitrogen. Okay, so these are all different ways to form an amide bond. You can go through it and find the ones that are as close to your starting materials as possible and then try it out in the lab. All right, so so that's for retrosynthesis. Again, I won't go into further details. So have a go at it and see if it's helpful. Hopefully you will like this new function. Now I'm going to finish off with the last thing again very quickly. So we've talked about ChemScape, retrosynthesis, and then there's one other new thing that you don't find in SciFinder, which is biosequences. So this again, can be another separate topic, but I'm just going to show it to you in case in the audience there are people who are doing sequence searching. So what I mean by that is the BLAST search. Okay. Typically people go to this website, NCBI, to do a BLAST search. So now you can do a BLAST search in SciFinder-n. The difference is that our sequence database is based on sequences that have been reported in literature. There are some overlap with the NCBI database, but in the future, I think maybe end of the year, we will be incorporating the NCBI database in SciFinder-n as well. But at the moment, it's just a BLAST search on the sequences in our own sequence database. Okay, so I'll just do a quick demonstration on the BLAST search. You can copy or paste in the box, or you can upload a sequence. So I'm just going to quickly upload upload a sequence, SciFinder-n training materials, sequences. Okay, so I have here an amino acid sequence that I've uploaded from a text file. So as my sequence type is a protein, I'm searching within a protein database. I'm going to just set it to the total number of results, 20,000. Under advanced biosequence search, you can change the different parameters of this BLAST search. If not, just kind of use the standard settings here, but just bear in mind that it will require, the results will have a minimum of a 90% query coverage. So if you want to have a lower coverage to get more results, then just remember to change it. So if all is good, just run the search. Okay, now once I've submitted the search, it doesn't look like anything has happened, right? Scroll down. Okay, you can see here that this is the search that I've just submitted and it's already complete. Okay, so just click on view results. So when you do a BLAST search, this will be the type of results you would expect. Okay, so it has found 1,944 hits. This is our query sequence, 192 amino acids. The first result here, it's aligned with a subject sequence, which is 193 amino acid sequence long. And in this case, it's 100% alignment. There's 0 mismatches, okay? And it will be able to see the alignment of our query sequence against the subject sequence. Okay, to know more about the subject sequence, you can go into the subject tab. All right, if there is a CAS registry number, it will be shown. In this case, this is not, this doesn't have a CAS registry number, but this is the full sequence. And although it doesn't have a CAS registry number, but we know it came from this reference over here. You can click on this reference to the reference button to view this pattern. Okay, now let me change. So this is another result, right? Again, our query sequence is aligned with another longer subject sequence. Again, this case is 100% alignment. So I'm going to change this to, 90% alignment so that I can show you some other types of visualization when there's misalignments. Okay, so typically for people who do blast search, if there are misalignments or mismatches, they will want to know where is it occurring. So you can see there's a visual here, but this is a more detailed visualization where the mismatches are highlighted, right? Mismatches meaning, you know, the specific position on the subject sequence is different from what we have in our query sequence. Okay. Similarly, you know, you have the references where the subject sequence is found from, and in this case, this subject sequence has a CAS registry number. Now, there are going to be some cases like this where it's grayed out. Okay, this is because, like I say, this is very new. So we have linked the sequences that are from patterns, but we haven't linked out to those that are found in non-pattern literature. So this could be a non-pattern literature. So it's not linked out yet. We expect this to be available maybe sometime in July. Okay, then you'll be able to link out to both patterns and non-pattern literature. So you'll know where this subject sequence actually came from, who reported it, what was it reported for. Okay, at the moment, only pattern sequences from patterns can be linked out. Instead of, you know, going through clicking on the individual references button, we do have the button at the top so that you can pull over all the pattern literature for your answer set. Okay, so this is that's all I'm going to say about sequences. As you can see, there are obviously two other types of blast searches that you can do. Again, maybe when the non-pattern literature function is available, then we can do, you know, separate session just on biosequences. Okay. All right, so that's all I have for my training. So let me just take a look if there are any questions. I see some questions here. Let me just go through it. Okay, so there was a question about ChemDraw. Okay, whether we can paste or link directly from ChemDraw software to SciFinder. So for ChemDraw, you can't copy and paste directly, like what I said earlier on. So you have to do one of the other different options. So maybe I can actually quickly demonstrate it. I do have ChemDraw. Okay, so let me open it up. All right. So in fact, if you have, no. So if you have, I think version 18.2 and above, you can check in the ChemDraw. All right, if you have the SciFinder-n API. Okay, so let me just quickly draw a simple structure. All right. So if I select this structure in my ChemDraw software, you can see that I have these certain add-ins highlighted. So this will be SciFinder-n. This is the old version. Okay, SciFinder-n. You can click on it and you can actually launch the search directly from CamDraw, all right? But it needs to be certain version. You can just double check if you have it. All right, so I'll just say open, and then it will run the search for me. The other ways that I talked about, the quickest way is actually just convert this into a smiles string. So if you go to edit, you can copy as smiles. All right. So this is the answer set that I have launched directly from CamDraw. Okay, but where was, okay, I'll just open it up here. I've copied the smiles, right? I've converted to smiles, paste it here. Okay, this is a smile string. Click on this button. All right, it adds the structure into the drawing editor for me. The other way is to save this as a mol file. So the CDX is the default, right? It's the CamDraw format. If you go to save as, you will see that there is this option here. Okay, so don't pick the V3000 option. Just pick the regular mol file. All right, I'll just replace this. Okay, so save it. Now I'm going to go into SciFinder-n. Let me get rid of this. Click on the import button and just look for the file. I think it was under my desktop. Okay. Then it imports it into the drawing editor as well. Okay, so 3 ways to kind of go around it, but you can't like just copy and paste directly. Okay, you can copy as, the only thing you can do is copy as smiles. Okay, you can copy as smiles and then paste it here. And then you can generate the structure from there as well. All right, let me see if there are any questions. Okay, so I don't see any further questions. So in that case, thank you very much, all right, for your kind attention. And remember, if you were using the old version, please do start using the new one. Maybe one more thing, since we are at this topic of the old version moving to the new version. If you have previously used the old version, go to your saved folder, and then just click on this migrate alerts and save. You have previously created alerts or saved any results in the old version of SciFinder, just click on it. They will migrate everything for you. Okay. If you're a new user, then of course, no need to worry about this. Okay. And then of course, the first thing before you can start using SciFinder-n, if you don't have an account yet, is to go to the library website, log on to the Easy Proxy, and look for the registration URL. So a lot of times people, I'm gonna log out. Some people try to use the registration link on the CAS website. Okay, this, right? Don't use this, okay? Because like I say, for universities, they your own unique registration URL, which you can only find it from your library website. Okay. All right. There's no other questions. I will send out the recording to everyone who have registered for the session. And later on, if you have any questions, don't hesitate to contact me. Okay. Thank you very much and have a good afternoon. All right. And take care. Okay. Bye-bye.
Bye.
Bye. Thank you. Thank you, everyone.
Thank you, Miss.
Thank you.
Thank you.
Thank you. Bye-bye. Thank you, Sharifa.
Thank you, Pamela. So,
Okay.
Dr. Doremi has left earlier.
Okay.
She conveyed her regard to you.
All right. Thank you. I'm happy she was able to at least attend a little bit.
Yeah, because she has another webinar at
Uh,
7, I think. Yeah.
Okay. Okay. Yeah. No worries. Anyway, the recording will be sent to everyone so they can review it again later.
Yeah. So you will email to them.
Yes. Because
Yeah.
I have all the email addresses of those who registered. I will send you the full registration report as well.
Yeah. Okay. Thank you. So for another training in October, and
Yep.
October or November. So we will
Yep.
discuss this near the date, right?
Yep, sure. Just let me know when you have fixed the date.
Yeah. Another one is quiz.
Yes.
Yeah.
So Adrian has mentioned it to us. And yeah, we will be you will want it during that time, right? During the
Maybe in October.
Okay, sure, no problem. We will set up a quiz, and then we can have the training in line with the quiz as well, so that they can test out their skills after attending the session.
Yeah, great.
Okay, no problem. We'll get that done. All right.
Yeah, thank you for your
All
time.
right, thank you. No problem. My pleasure. All right, bye-bye.
Bye.